Hi, welcome. My name's Andy and this is Car Engineering Simplified, where I'll be taking you through the basics of how a car works to some of the more advanced engineering principles. Before we get started with today's video, can I ask you don't forget to check out my other social media channels where I'll post information about new and up and coming videos and car information in general. I'll post the links at the bottom in the description of this video. So let's get stuck in today's video, an overview of the braking system. So let's start off by looking at brake fluid. Not all brake fluid is the same, but it has to cope with similar situations. It has to have a good viscosity, which means it doesn't change its ability to flow when temperature changes. It doesn't get thick when it's cold or thin when it's hot. It has to be able to lubricate the components within the braking system. Just like our engine oil has to lubricate moving components in the engine, so too does brake fluid. It has to be non-corrosive. We have rubber seals, we have metal pipes, and the fluid can't interact with those and start to degrade them over time. Like I said, it has to cope with extreme temperatures, low freezing points, -10, -20, -30 degrees C. It has to be able to hold that viscosity and still operate as it should. On the flip side to that, it also has to be able to cope with extreme high boiling points. Imagine the scenario where your car's loaded up, you're going on holiday, you're going down a steep hill, and you're using your brakes constantly to control the vehicle speed. That generates a great amount of heat in the braking system, and again the brake fluid has to be able to cope with that and operate correctly. So we have the SAE, the Society of Automotive Engineers, and the DOT, Department of Transport, and they carry out some tests and give us what we call dot numbers. Traditionally we've got dot 3, dot 4 and dot 5.1 for your main road going vehicles, and dot 5 is the odd one out here. It's generally used on military vehicles. So dot 3, dot 4 and dot 5.1 are all glycol based fluids, and they can be mixed together and used with each other. However, I'd strongly recommend that you always check your manufacturer's recommendations and use the brake fluid that they suggest. These three brake fluids are what we call hygroscopic. Hygroscopic just means that it starts to attract the moisture from within the air, so it naturally degrades. When you open a can of brake fluid or the brake fluid that's in your car, it starts to attract these molecules from the air and it mixes with the fluid and it starts to degrade and lower the boiling point. We have two tests. We have what's called a dry boiling point and a wet boiling point, and the dry boiling point is when the brake fluid is brand new, it's just been opened, and you can see here dot 3 has a boiling point of around 205 degrees C, 401 degrees Fahrenheit, 230 degrees C, 446 degrees Fahrenheit for dot 4, and dot 5.1, 270 degrees C, 518 degrees Fahrenheit. Now as these get used over time, they absorb the moisture and that boiling point starts to reduce, like I say. And you can see from the other side, the wet boiling point test, it's around about a 30% drop. So for dot 3 we go down to 140 degrees C, dot 4 155 degrees C, and dot 5.1 190 degrees C. The one we missed out there was dot 5. It's a silicone based fluid and this cannot be mixed with the other three. If it is, it starts a chemical reaction and it will start to degrade all the rubber seals and rubber pipework in the brake system. But this is generally used for things like military vehicles when they go off into war zones and they can't come back and get serviced on a regular basis. Your local garage recommend that your brake fluid should be changed roughly once every 2 years, but also going on these wet and dry boiling point tests, it could be slightly shorter. Okay, so now if we look at how the manufacturers get the brake fluid down to the corners, down at the road wheels to operate the brakes, and they use what's called a split system. This split system can be either front to rear or diagonal corners. The diagonal corner one is the one that's most commonly used on today's vehicles. It has efficiency benefits and also safety benefits. If we think about all four corners of the vehicle, not all wheels do the same braking. The front two brakes will operate at around about 60 to 70% and the rear two brakes around about 30 to 40%. If we had the front to rear split and for some reason we had a burst in one of the front brake pipes, instantly our efficiency for the braking is going to be down to at least 30 or 40%. Whereas if we have the diagonal split and we have a burst in one of the lines, we're still always going to have one front wheel and one rear wheel operating, which is going to give us at least a 50% brake efficiency and be able to pull the vehicle up nice and straight and square. So next I want to look at the heart of the brake system, the master cylinder and the plastic fluid reservoir that sits on top. You may be able to recognise this component if you have a look under the bonnet of your car, and you'll be able to see the plastic reservoir with a minimum and maximum level of fluid on there. Just a word of warning, you should never top up a brake fluid system. If that fluid level is getting to minimum or even below minimum, don't top it up. That's the time when you need to go to the workshop and get it sorted. There's two possible reasons why it's low. You've either got a leak and you don't know, or your brake pads are running low and that requires more brake fluid out of the reservoir to keep it in contact with the disc. Therefore, the fluid level will drop. But let's have a look at this component now and how does it work. Well, this is called a tandem master cylinder, and this is the bit that makes us able to have this diagonal split system. If we look how it operates here, we have our foot pedal inside the vehicle, the driver operates the foot pedal and he pushes on this push rod. This push rod comes into contact with what we call primary piston number 1, and that starts to push forward. It then starts to close a port here which just allows fluid transfer from the reservoir into the master cylinder itself, closing that off, and it starts to generate pressure in its little chamber in front of the piston. Fluid can't be compressed, it passes on the pressure equal and opposite in every direction, in which this is what it does, passes the pressure down the brake pipes and eventually comes to the road wheel where it operates that particular brake, in this case a disc brake. Then what happens is this fluid pressure generated in front of primary piston 1 starts to interact with the back of the secondary piston, or piston number 2, and it starts to push the secondary piston number 2 on its cylinder, and it starts to generate fluid pressure in front of piston number 2. That fluid pressure is passed on down its brake pipes and it goes to whichever road wheels that is piped up. When the driver releases the foot brake, we have return springs that push the pistons back into their natural resting positions. So let's have a look at how the master cylinder allows us to achieve at least a 50% braking efficiency should we get a leak in one of the circuits. If we focus on this side of the diagram, what we can see is our master cylinder reservoir. We've just raised it slightly up so it helps us to visualize things, and we've got the pipe work coming out. Driver operates the foot pedal which pushes on the piston, moving primary piston number 1, generating the fluid pressure in the circuit and then operating the 2 brakes that the circuit number 1 is piped up to. Piston number 2 starts to move due to the pressure generated behind it, and unfortunately it's got a leak. We don't know why it's got a leak, but it's got some sort of leak, and the piston starts to move forward, and all it starts to do is dump the fluid through that leak, draining one side of the reservoir. If we just go back, you can see there's a baffle separating 2 chambers in the reservoir. So when we do have a leak, or if we do have a leak, it will never completely empty the fluid reservoir, it will only empty one side. If we flip it and say we've got a leak on the primary circuit, how is that effective? So driver operates the pedal, piston number 1 no longer can generate pressure, it's got a leak, so it starts to move forward through its cylinder, dumping the fluid out of its chamber. You can see now it's starting to drain the opposite side of the reservoir. But we said previously that the pressure generated in front of piston number 1 moves piston number 2. We're no longer generating any pressure, so we have to make a physical contact and move piston number 2 mechanically. Instead of moving it hydraulically, we now have to move it mechanically. Piston number 2 starts to move, generating its pressure after it's covered up its compensating port, passing pressure down the lines and eventually to the road wheels, and they achieve a 50% braking in circuit number 2. If you've ever been sitting in the driver's seat of a car being pushed with the engine off and you've needed to use the brakes, you will have noticed that the brakes are ineffective. And that is because of this component here, the brake servo or brake boost. It sits between the driver's pedal and the master cylinder, and again you may recognise it underneath the bonnet of your car as a large black circular chamber. What we've got inside is a rubber diaphragm creating two halves of this chamber. One half as a return spring that when the foot brake is off will push the diaphragm back to its natural resting position. We have a couple of one-way valves situated here and at the top, and this one-way valve here is piped off to engine vacuum, which on a petrol engine will be provided by the inlet manifold, and on a diesel engine will be provided by a mechanical vacuum pump. The other side, the one-way valve, will open up to atmospheric pressure. So when the engine is on and the foot brake is not being operated, both sides of the diaphragm are equal pressure, and that is engine vacuum pressure. As the driver drives down the road and operates the foot brake, he uncovers and opens up the one-way valve at the back here that allows the right-hand side of the chamber to fill with atmospheric pressure, which is 14.7 psi or 1 bar at sea level. So now we have a pressure difference in the chamber. We've got higher pressure on the right hand side, lower pressure on the left hand side. So that causes the diaphragm to move towards the master cylinder and therefore increasing the force going into the master cylinder. Simple calculation to work out is force going in equals pressure multiplied by area. The pressure is provided by the driver's foot, so that would remain constant. The area has now been vastly increased because it's now the area of the large diaphragm. So the force going into the master cylinder has now increased greatly. The final section of today's video, I want to look at brake pipes. And these can be split into two categories: solid metal pipes or flexible pipes. Flexible pipes can also be split into two categories. We could have rubber hose, like this particular one here, or a braided hose, like this particular one you can see here. Now essentially they do the same thing. A braided hose will be found on a more high performance vehicle where greater pressure is required in the braking circuit. If we concentrate on the front steered wheels, what you will always see is a flexible hose of some sort, braided or rubber, going to the brake caliper. This will allow for suspension travel up and down and steering axis left and right. If it was a solid pipe, the constant movement up and down and left and right would eventually fracture the metal pipe and cause a leak. Depending on your vehicle suspension at the rear, you could find either a single rubber hose down the centre of the axle with two metal pipes going to the road wheels, or you could find the same setup as you would at the front wheels. Now your metal pipes from manufacture will be steel and they'll be coated in a plastic. The last 2.5 centimetres, 1 inch of the brake pipe will be exposed metal and the plastic will stop. And unfortunately over time this is where it will start to corrode and perish, eventually requiring replacement by the workshop. Now when these are replaced, they will be replaced with a supple copper brake pipe that the technician can mould and shape into the original, to match the original brake pipe so it doesn't hang down and catch on anything. That's it for this week's video. I hope you've enjoyed it. I hope you've learned something new. If you have, great, give it a thumbs up. Even better, click subscribe, keep up to date with all the new content that's going to be uploaded. I'll post links to the other social media channels. I've been Andy. This has been Car Engineering Simplified. Thanks for watching. See you soon.